Yeah, I want you to introduce to Nix, which is a couple of things. The first one is it's a pure functional language, and it's also a package manager, and we will focus on the package manager first, which you could basically use as a replacement or in addition to your existing package manager. One of the great benefits about Nix packages is that it has more than 80,000 packages out of the box, which is pretty impressive, I guess. It's more than anyone else has. So I don't know whether you know this website here. It allows you to inspect all the different repositories out there, and also has some graphs to give you an idea of the different package managers out there. And you can see this is Nix packages unstable, so there's a rolling release version of the package manager or of the packages. And they also do a release twice a year in November and after April. And these are the older versions of Nix packages. Then comes the Arc user repository. And that's everything else within the Linux world. So that's why they have another picture just from everything else, so you can actually see where's my Ubuntu, my Fedora, and the base Arc Linux repository and stuff like that. So what you can see to the right is the number of packages. So the more right, the more packages, and the higher, the more fresh versions of the packages. So even if you have multiple packages, you might not have the up-to-date versions. But these are absolute numbers, so it doesn't mean that all of those packages are up-to-date, but in the whole amount of fresh packages is, of course, the largest one. So if you are interested in Nix and NixOS or everything else, there is this website called nixos.org, where you can find all the informations and some examples. And there's also a learning introduction, how to install Nix, how it works, some guides for fancy things, and then an overview of the different parts of Nix itself. First of all is the Nix manual, which is referring to the package manager and the language. Then we have Nix packages, which is basically the default repository with all those 80,000 packages. And then there's also the operating system. Right now, this device still uses Ubuntu LTS. In addition, I've added the Nix package manager and a community project on top of that. So just to give you an idea what it's capable of, in addition to what I'm showing you in the next couple of minutes, you can just create ad hoc developer environments and just say, oh, I need Python version X and Ruby version this one, and just collect it together and have an ad hoc environment and throw it away afterwards. It tries to be reproducibility, so you can pin exact versions of the package states and say, all my colleagues will use the exact same version which I've used. So even if you are, so you can say, okay, the version of right now, today, from the package manager, and you will receive the exact same setup in 2 or 4 weeks, instead of usually you just say, okay, the version my system knows right now, please install version 8 of PHP, for example, and then it will be a different version once a new bug fix release comes out, for example. You can integrate it into GitHub Actions, so you even can have the exact same environment on your local machine within your CI system and even on the production system. You can use that one to create your Docker images if you're still used to Docker. Install it on multiple different platforms like Raspberry Pi, different architectures, and even cross-compile via virtualization, so you can just add one configuration line, and I could compile ARM architecture packages on my machine, even if it's not an ARM. So that's just an outlook what you could do, in addition what I will show you right now. So how I actually use it is I'm using this addition, which is called Home Manager, which is a community project built on top of all those kind of things. And I just call Home Manager switch, and it will switch my current system to my current definition of the system. So that's the output, and I'm done. So now I have stuff available like Git, for example, PHP and Composer on this system still comes from Ubuntu. So if we say which PHP, we will see that's on the normal folders from Ubuntu. But on my NixOS, for example, I don't even have PHP available on my command line because it's not defined anywhere, because I need different PHP versions, and these depends on the project, and I don't need one specific version on my global system. So how does that work? I have one configuration file, which is the home Nix file that's read by the home manager and receives a final result configuration, how my system should look like, and then will ensure that will install all the dependencies, create the configuration files, and in the end will do the switch. So the home manager itself will first of all build the configuration and then activate the configuration. So 2 steps which are combined in the switch command. The end result is more or less working by adding up one path to the global path variable. So you can see all the usual things, and the first one is this home Daniel's Nix profile bin, which itself is a symlink. And this one is symlinking to the actual current configuration. So when I do an update, it will replace the symlink and I have my new setup, which also allows me to roll back. So in case I'm doing an update every time in the morning, and I then notice I'm working on a bug fix for a customer and my editor doesn't behave like usual, I just do a rollback, work on the bug fix for the customer, and then we'll figure out what broke during the system update later on in the day when I have the time to do that. So if we have a look at that one, we will see all those symlinks. And if we have a look within the folder, we can see that you can find all the I need a tmux session. I can't work like that. Nix profile bin. No. So you can see all those things are now installed via home manager. So my Z shell is installed via that one, YouTube downloader, wget, VLC, my terminal SQLite, Nix itself, KeyPass, many desktop tools, Git, my Firefox. All those kind of things are installed through the home manager and configured by that one. The same is true for all the configuration files. So if you have a look at the Git folder, we then can see that all these files that you use to configure Git are indeed just symlinks to the so-called Nix store where everything is stored. So that's the location where everything is. And every place that's used to look up those things is just a symlink to this single location. So that's how it can do it instantly, more or less, and just replace all those symlinks in order to switch your actual current system. Of course, those configuration files doesn't look as pretty as handcrafted ones because they are auto-generated. In this case, it's pretty simple because it's an ini file format, but some others look very clunky, like your typical HTML output of typo 3. If you create it with Fluid templates, then you have huge blank lines and stuff like that. And let's have a look at how I actually install and enable and configure Git, for example, because I guess Git is one tool that most of you already know. I'm like clean structures, so I have one file per program. So in this case, home programs Git is where everything related to Git is stored within. And that's the content of the file, and you can see the syntax looks pretty much like TypoScript or JSON, but that's a custom language called Nix. What we retrieve here is like dependency injection, so we can require dependencies. In this case, the whole package repository with all those 80,000 packages. And in the end, we return a so-called set, which is like a JSON object, where we, for example, say, okay, please enable Git in this case. And please configure my username, my email. Please always sign my Git commits by default. These are my Git aliases. This is my global Git ignore. Please enable diff so fancy and configure diff so fancy. And for everything where there is no predefined configuration within this NIX, I can just use extra configuration and add everything else on my own. And this will then be parsed and will be used to generate the git configuration files, the git ignore, and to install all those necessary dependencies. So that's a pretty small and simple thing. I'm also using NeoVim as my daily driver, like you use PHP-SOM or something else. And that looks pretty much the same on the first hand. So we say, please enable NeoVim for myself. And then please install also my plugins. So I don't care how many plugin managers are out there for my NeoVim. I just use my package manager that I'm already using, Nix in this case, which already has many, many different plugins. And the easiest one is just say, please install a syntax for TypoScript, please install this plugin. But I also can say, yeah, please install this plugin and read the configuration for this plugin from another file. So in this case, a Vim file within my repository, so I have the syntax highlighting and stuff like that when I edit this file. And I can go even further and do stuff like that. So in this case, again, we say, please install a plugin. And in this case, we say, please install this plugin, which is Fuzzy Finder written in Lua for NeoVim. But please override some attributes of the definition of this package. And in this case, please add a patch. So if I don't know how many of you are using Composer patches. What I'm doing here is basically exactly the same on system level. So I say, please install a plugin which is defined within your package repository, but please modify the source code with this patch applied. And that's, for me, the game changer. That's open source. So now I don't only have open source and can download it and can modify and can compile my own, but someone else already did all this stuff for me, defined how to compile everything, how to install everything, and I just can apply patches and really make use of open source. So that's one huge benefit when you use Nix, because it's a source code-based package manager like Gentoo and some others. And that way it always has recipes how to compile the software and how to install the software. It comes with a cache, like many others also do, so I can download the precompiled versions. I don't need to compile everything on my machine. Regarding Green IT, not everyone needs to recompile. But of course, if I change the source code, then it will compile on my machine because there is no matching version out there. Another thing is I'm using a programming language, Nix in this case, which allows me to use all the feature sets of a programming language. Now I can program my configuration. So in this case, I'm configuring the language server protocol for NeoVim. So language server protocol is something invented by Microsoft. They are not doing only bad things, but also good things. And that one says, okay, you can use a stupid editor, and someone else can implement language servers for different languages like PHP, TypoScript, TypeScript, JavaScript, stuff like that. And then we have this protocol which defines how to communicate between both, and then your editor can become a full IDE. And in this case, I'm adding PHP Actor as a language server for PHP, but normally it would just look for the binary PHP Actor in my path variable. But now I don't want to clutter my whole system, because the only place where I need PHP Actor is within my editor. I don't need it anywhere else. So what I can do right now, I can configure the plugin to use this command when using PHP Actor as a language server. And that way I'm referring to the actual PHP Actor package within the package manager, which will be resolved to the installation path within the Nix store, and then tell him, please add binary PHP Actor, and then it will resolve all that, and the paths are hard-coded within the configuration. So this software is installed out of the box as a dependency, and then the configuration has the actual path without cluttering anything else within the system. And that's also very, very nice. So I have another plugin installed, which allows to validate all my configurations files. So I'm using YAML-lint because Typo3 has many YAML files nowadays. The same for XML because of the XLIF files. Git commit with git-lint when writing git commit messages. A language tool when writing documentation. And an RST check when writing documentation. And now I can just say, please use these tools, and they will be installed and properly linked, and it's just working. And that would be much more complicated in other systems. You either need to remember, okay, YAML-lint is in Python, so maybe it's not even there, so I need to install Python 3 first of all, then pipe 3, please install YAML-lint, then figure out where it's installed and how to connect it to NeoVim, and that way I just can say, do it, and you're done. So that's also one huge profit you get out by using stuff like that. So all of that is working because someone else already did some work beforehand for myself, which is a so-called module. So the home manager repository basically is a huge set of so-called modules, one for example for Git, one for NeoVim, which define some options, like for example, okay, please give me a list of plugins I should install. And those modules then work based on the configuration we have seen right now, and we'll do everything what's necessary in order to create all those configuration files, place them in the right location, and stuff like that. I've created some smaller custom modules, so we can have a small look. Yeah, so that's how a module looks like. So it's basically more or less the same. We again return a set, but this set always has to provide options, which are the options that are available to the outside, which I can use to configure something. And then the config object, which will be used, it will receive all the final configuration and then can work on that one. So for Mailhawk, I also add the best practice way. You can enable it, set it to true or false. Then where do you want to store things, either in MailD or memory. So I can even say this is a typed language. So I can say the only allowed values for the storage are MailD and memory. If I had a typo and would write mildr or something like that, then it won't even compile my system and will just print me a message, oh, you have a typo here. The only allowed values are those two. So I can't even end up with a broken system just by accident while having an issue within something like that. Same for the ports, for the different ports. Yeah, and then I have the configuration, so which basically says, okay, CFG is the final configuration result. So if it's enabled, then at a systemd user service called Mailhawk, which again is a module providing systemd service implementation, where I just configure my systemd service, and that's how I created my own module to install Mailhawk as a systemd service. So that's also pretty nice. Yeah. Any questions so far? You just raise your hand whenever you have some questions. No. No questions yet. Yeah. Okay. What you probably also would like to see are those developer environments. So if we have a look at one of our customer installations, we have, for example, here a Typo3 extension called watchlist, which is typical setup with class configuration, resources, tests, of course. I'm using Codeception because I'm a backend developer and don't want to add JavaScript just to write my own tests. And what's special here is this shell.nix file. First of all, let's use it. I have a short alias NSZ for Nix shell with Z shell, because the default Nix shell would use a plain bash shell, because this is a feature by accident. The people working on Nix and the Nix packages needed a way to debug the compilation of all their programs. So how I need to debug the compilation of a program, and that's why they invented Nix shell. So it will hook into the whole compilation process, and you can execute it step by step and investigate. So, but by accident, this also allows you to start a developer environment with all your dependencies right there. But that's the reason why it uses bash by default and not something else, and why I have this alias. So it will now download everything that's not on my machine right now, just if you would start ddev or Docker for the first time. All of these things are the pre-compiled versions. Should have used something where everything is installed already. Okay, we will use the time to have a look at the file content. Whoops. Okay. Yeah, I don't know what's happening here, why it's so slow. So first of all, we don't have dependency injection more or less right here because there's nothing from the outside that's calling us like the home manager or something like that. So I can say I need the packages. If they are not provided, use that as a fallback. And in this case, I'm importing from a global context the whole current Nix packages definition. Then we've already seen that beforehand, this let, which is basically a local variable definition, which is then important and available within here. So what we do here is basically install a make shell with all of our inputs like project validate composer, project validate XML, project coding guideline, project test acceptance, and a small shell hook which just exposes environment variables. And yeah, so now we are within this Nix shell. My wrapper also alters the prompt so that I can see whether I'm in a Nix shell, which is yellow for myself, or in my normal shell, which is blue. And now I have further things available, like, okay, please do the coding guideline checks, which is not available in my normal shell. I have custom stuff, but nothing with the project. So these are only defined within this subshell. And that way I can define everything I need, like, okay, I need this PHP version, I need the composer version for this PHP version. How does a project install look like for me? How does a validate composer look like? What dependencies do I need for validating XML, and how does it look like? And how does it look like to execute my acceptance tests? And the cool thing about that is not only that I can use that on my local machine, but as mentioned earlier, also within CI. So executing acceptance tests on the CI is just one single plain command, because Nix shell is not only available as an interactive shell, but I can also pass the argument run and tell him what to run. So I just say start a Nix shell, so with everything I had just locally, and then please execute the acceptance tests. And then it's just running my acceptance tests. So I have one action, which is the install Nix action. So Nix is available, and then I just say, please execute. So that's, I guess I never saw an easier CI setup, which you could also run easily on your local machine, without all this overhead of, okay, I need virtualization on top, especially on a Mac, because Docker is using Linux kernel features which aren't available on BSD. And all this headage, it just runs natively because it's just doing a bit of symlink magic and environment variable magic, and that's it. And Yeah, and there's one single command to garbage collect to your store. So it will erase everything that's not needed anymore, like all these things we installed just for the shell. And yeah, I find that very impressive and cool. So how it's actually working is that we say, okay, for the shell, please install that one. That's of course not available in the Nix package repository, so we define it here. And what we have is also some called easy or simple builders. So for common use cases like, okay, I just need a small bash script as application. So that's what Write Shell application actually does. I provide a name, which is the name of the file, of the binary file, which I can then call in my shell. And I can define, you need these dependencies. So these are available within the bash script, like Gecko driver, Firefox, SQLite, PHP 8, and define above project install. And then my bash script say, okay, please install, define the instance path, create it, and run conception tests. And the cool thing is, for example, if I won't quote that one, project root could have blank a space somewhere. So that wouldn't work because that one wouldn't be one argument, but multiple arguments. And part of the builder is shell check. So the typical build normally is, okay, fetch some sources from somewhere, which in our case is just our text of the bash script. Sometimes it's fetching something from GitHub or somewhere else. Then prepare something, so typically make configure from older versions, then install something, and then check whether everything is working. So normal C programs have make check, make install, make test. So these different phases. And that's also implemented for that one. So I get information out of the box. Oh yeah, I've run shell check to test your shell script, and shell check said you should better double quote that in order to prevent globbing and other magic, which you won't expect. And so that one also trains you on writing better shell scripts. And that's also the process. So like with my system configuration, I just changed something, started the process, and it needs to recompile it because it's not available in the system right now. Then does all of that and said, okay, that's broken, I won't go any further. Now I fix it and should be there more or less instant because it sees, okay, that's the version I already have, so I don't need to do anything. So let's have a look at how this looks like. So if we have our custom, our project test acceptance, then we can see, okay, that's where it's defined. And if we have a look at that one, I'm used to the other keyboard and the control key is somewhere else. Then we can see that's the end result. So first of all, this shebang is also against the Nix source, so I can see, okay, this is using bash 5.2. Then it also sets some proper defaults like exit if there's any error code other than 0, so don't continue with the bash script. I don't remember no unset right now. And pipe fail is used if you pipe commands behind each other, then it won't use the last exit code, but if anything in between doesn't exit with exit code 0, then it will also stop. So these are the defaults added by the builder. And then it's also adding the path so that everything we have requested as a dependency. So in this case, PHP 8, Firefox, Gecko driver, and everything else will be available. So if we split it up, we can see, okay, this is our project install, this is SQLite, this is Firefox, and everything else. And that way, by just altering the path within the shell script, it will just work regarding using the defined dependency. So that's not much magic in the end. It's pretty basic and understandable. But that everything is working together and how it's put together, that feels like magic in the beginning. But in the end, you have everything open source. It's right on your device, and you can have and inspect the files, and it's in the end not that complicated. Yeah, so what it's not a replacement for Docker in case you want to run services based on your projects. So for example, if you need different versions of Solar in different projects, because it's just this simple magic of shell scripts, path variables, and stuff like that, it won't start your Solar services for you. It's also not security related, like what the real idea of Docker is. It wasn't to create your development environment. The real idea was to use all these kernel features regarding security to isolate different things, so they don't have full access to your full device. So they only have access to the mounted volumes, to the mounted file system. You could limit the resources, how much CPU should you use. All of that is not possible here because that's not the target. The target is to have a cool package manager, build system and configuration, and not to have all these security features. Also it solves the issue that some distributions have, because everything can define, I need this version of a dependency, and then it will just be installed alongside because it's linked against each other. It will just work and isn't in the way of every other software on your system. Yeah. I should learn to have a look how long I have to speak at the beginning. I don't see the cursor. Okay, so 10 minutes left. Do you have any questions now? Yeah.
Once you've set up a whole script for setting up your environment, and you want to do that, for instance, for running tests on a different Linux server, test it, what are the requirements for that server? Do you need to install something first before you can set up your script?
Yeah. You need to install Nix in order to execute the Nix commands. But that's basically it. So if Nix is there, then you can just call, for example, your Nix shell, like we have seen in the GitHub action. The action itself just installs Nix, and then you can just execute the configuration. The same is true if your server has a different architecture than your machine, and maybe your machine has more power because you have a virtual server or something like that. Then you could cross-compile, as I've said at the beginning. So you could configure your Nix system to emulate the architecture of the other server. So it would bootstrap a virtual machine with this architecture, would use that as a remote builder to compile all your stuff. And then, just like with Docker, you could say, please export from my storage to the remote storage over SSH, and then it will copy all those compiled files over to the other system. So that's also possible. But I guess, therefore, you need Nix installed and the Nix store on the other system so it can communicate. Yeah. And if you are regarding DevOps, there are 4 or 5 different projects and different approaches that allow you to use all this Nix stuff for DevOps and managing multiple machines at once. Yeah. Further questions? Yeah.
You mentioned installing plugins, for example, for VI using Nix, but this depends on the community providing modules. How is the community active, and what is available now, and are you still always up to date with newest version, or do you still need to, in some cases, to use other package management on top of that, or besides that?
Well, as we have seen at the beginning, it's a package manager with the most packages. So, yeah, sure, they don't have everything, but it's more likely that you will end up using Nix in order to install something than to use some other package manager to install something. If you lack something, like for example, NeoVim plugins are a good example, then you can, of course, just edit yourself, because it's not that complicated, especially for NeoVim. I can show you that. So, NeoVim. So, for example, my oak color scheme isn't available in the package repository because I didn't contribute it upstream, because I don't think many people will use it. So, because Vim is very widely adopted, at least outside the Typo 3 community, there's a builder for that. So I can say, okay, within packages, there's a Vim utilities with a build Vim plugin from Nix. And then I can say, yeah, that's the name, that's the version, that's the source code, and that's it. So, and that will just install and it will work because it's so trivial and so there are so many plugins already, so they abstracted away what's necessary in order to create a Vim plugin, and all I have to do is to provide the source and pass it over to that one. Of course, it's not always that easy, but especially for the widely adopted languages, there's more or less every time something like that already available.
Plugins for PHP Storm using this setup? You don't use it,
I don't use PHP Storm, so I didn't have a look at that.
Because I think there's public available repo where you can...
PHP Storm is also special, I would say, because it's an unfree license, so it can't be distributed. Because they just distribute open source licenses by default because they don't want to get into legal issues. Oh, you distributed something you shouldn't distribute. So you explicitly need to set the unfree option to true. So you can do that per package, but you could also do it on a global level. And then it would just download the file from the official sources because they can't distribute it. In case it's something, and sometimes they also can't build it and stuff like that. So unfree software is also supported, but will then be fetched from other sources, so it's out of the control of Nix itself because of legal issues. You could also, in that regard, so that was just an example for new Vim plugins, you could also use overlays. So what you basically do is you have different channels. So that's a concept like you have for other distributions like the repository. So there's the Arc repository and the Arc user repository. So you can add multiple repositories. You have the same for Ubuntu, for example, where you can add further PPAs. And you have the same for Nix packages. So the official version is installed by default, as usual. There's another one, just like for Ubuntu, where all the older PHP versions are provided, because Nix says we don't maintain software. We maintain the definitions how to compile something. And if PHP says, okay, it's out of support, then we don't provide it to our user base, because that would be insecure. So just like with Ubuntu, you can say, okay, please add another channel which is still providing the older versions to me. And you can overlay the end result of all those different repositories. So you can alter something or add new stuff on top of the end result, for example. So I'm using a different chat client called Pigeon, which is using Purple as a library underneath, and which just provides the UI for chatting and doesn't implement all the protocols. It comes with some defaults, but for example, Slack isn't one of the defaults. And the Purple Slack installation had some issues for me, so I'm say, okay, just like we have seen with overriding with patches, I can also do that on the global level. And I can say, okay, please use the Purple Slack one, but override the version and override the source code, because that's the version I know that's working for me. And I can add a couple of patches because I've tried to understand C code and added some patches with additional commands which I needed to work with Slack. And you can do the same thing in order to add something that's not supported by default, but I guess I didn't do that. No, I just have, yeah, I guess that one. Yeah, so in this case, it's something that wasn't available out of the box. I have customers using Microsoft Teams, and I want to integrate that also in my chat client, so I don't have all these Firefox instances, Chromium instances, and chat instances, but just my chat. And it wasn't available, but it's pretty simple to install. So that's what the very basic minimum is. So every installation recipe is called a derivation. So that's what we are doing here. We create a new derivation, calling it Purple Teams, defining the version, fetching the source code again from GitHub, altering some configurations for the compile step, add what we need as build inputs, and that's it. Then it will just execute make by default, all these concepts that are more or less the same for most of the projects, but I could alter every single step here. And then I've already installed this little C plugin for Pigeon, which wasn't there beforehand. So it's most of the time not that hard. At least if you have simple software. Of course, the more complex the software is and the more dependencies you have, of course, that will become more complex. Yeah. So I'm not a C developer, but that, yeah, you can see it's just a couple of lines. So the real issue, like most of the time, is figuring out that you need these two variables, and then, yeah. Further questions? None. Okay. And I guess we are also done because it's half. Yeah, so just in time. Then you have 50 minutes and can visit the next talk. Yeah, thanks.